And we're back here talking about the change in base formula. Okay, so basically you could change it to either log base 10 or change the logarithm to natural log, and you can do either one in the calculator. So let's look at some examples of changing the base. Ta-dam. All right, so it says evaluate log base 5 of 19. Okay, so just a reminder what that means is you're figuring out 5 to what power. Okay, we're looking for the power here. 5 to what power gives you 19. Okay, and well, 5 to the second power gives you 25, and 5 to the first gives you 5, so it has to be between 1 and 2. We don't know exactly what it is, and it's probably some very long decimal approximation. So what the change in base formula allows you to do is rewrite log base 5 of 19 as two log base 10s that you could use in the calculator. So it would be log base 19 divided by log base 5. And then you could just do either one separately and get your final answer. Or what I like to do is just, put it all in the calculator at once. That way you have less room for approximation error. So either would work there. All right, next example. We're going to write it only using natural log. So we could actually do the same thing with the previous problem if you wanted to. It would be natural log of 19. You could try it out. Write this and figure out what it is with natural logs. Do natural log of 19 divided by the natural log of 5, and you should get the same decimal approximation. But here we're doing something else. We're rewriting this log base 5 of c minus d. So it'd be natural log of c minus d divided by the natural log of 5. Okay? And then you might be thinking, wonder if I could distribute here. No, you cannot distribute a natural log into a quantity. Remember, you cannot distribute functions. You can only distribute numbers. All right, so that's it for that one. This one says write the expression as a single logarithm. So what we're going to actually do here is combine. Okay, this is no longer using the change of base formula. This is just a completely different example. So we're actually going backwards. Instead of taking a logarithmic function and expanding it out, we're taking one that's expanded out already and we're condensing it as a single log. So when you're doing this, you first want to, if there's a number multiplied by the log, you want to use the power rule and put that as an exponent. Okay, so that's what we did. We used the power rule. So the general thought is use the power rule. You want to work your way backwards. Use the power rule, use the product rule, then use the quotient rule in that order. So if there's a number multiplied by the log, bring it up top first. And then, since it's subtracting of two logs here and they both have the same bases, you could use the quotient rule and write it as a division. Okay, and then the log, remember, is base 10 here. All right, so here's another example of change of base. Okay, using the change of base to write this using only common logs. So you have log base 4 of 10, so you could rewrite it as log base 10 of 10. Okay. And on the bottom would be log base. Remember, on the bottom you write the old base in the denominator. So log base 10 of 4. Okay. Of course, the understood 10 is there, which you don't see. Now the top just becomes 1. If you want to simplify log base 10 of 10, that's because 10 to what power is equal to 10? Oh, that's just 1. Okay, so log base 10 of 10 is equal to 1. So you have 1 over log of 4. And then if you wanted to do a decimal approximation, you could, but it says not to in this case. All right. There's an assignment here from the book, which you guys don't have to worry about. But there's a problem in the book that might be helpful for, I don't know, the math Excel that I'm going to give you guys to do tomorrow. And that is to graph a log. Okay, graph this log, and now you can't graph this in the calculator because your graphing calculators don't have log base 7. So what we have to do is do change of base on it. Okay, and so I'm actually going to change it to a natural log base, but you could change it to log base 10 if you wanted to. It would basically be the same exact graph, okay? So we're rewriting this using the change of base formula, okay? Y equals log base 7 of x. We're changing that to natural log, so we have natural log of x over natural log of 7. Remember, the old base goes in the denominator, okay? And then so what you can actually evaluate now is what natural log of 7 is, okay? Natural log of 7, you could pull that out, and so that's like a vertical shrink when you pull it out because it's a number less than 1, so it's going to actually be shrinking the natural log graph by 0.5139. So it's like roughly 51% of its old size, okay? 0.5139 is what 1 divided by natural log of 7 is. And you would just do that in the calculator. And then you can actually put that in the calculator to see what the graph would look like, which is cool. Okay, or just graph a natural log function and then just shrink it by that, okay? Which is kind of hard to do by hand for sure. All right, so hope this helps you with this lesson, and make sure to do the Math Excel assignment, which I will either post today with this or I will post it tomorrow. And have a great day, guys. Take care now. Bye-bye.